All right. We're really excited to have Dr. Kingsley join us today. So really thankful for you to join us, talk about the Flint Water Crisis. Dr. Kingsley is an associate professor of chemistry and biochemistry at the University of Michigan, Flint, where he teaches and conducts research in inorganic and green chemistry. He's a co-developer of the nation's first Bachelor of Science degree in green chemistry. And excuse me, his work focuses on the design and synthesis of sustainable chemical processes and materials. Drawing on his experience during the Flint Water Crisis, Dr. Kingsley will highlight for us how chemistry can serve both community resilience and environmental responsibility. So with that, I'll let you take it away.
Thank you. Thank you for the invite. We talked about this last, June, probably at the Green Chemistry and Engineering Conference, and I agreed to do this. And then for a variety of reasons, forgot that I had agreed to do this. And Dr. Prescott reached out on Monday, said, so excited for you to come on Thursday. And I was like, oh man. And then I had like 90 ideas of what we could talk about. She said, you guys might be interested in the Flint Water Crisis. And so this talk isn't going to be super chemistry heavy. We are going to talk about water quality control in general, because I think there's a lot of misconceptions out there about how some of the things happen in relation to why we treat water the way we do, and ultimately talk about what happened here in Flint, and give you a perspective from somebody who was on the ground at the center of it in a way professionally. I don't live in the city of Flint. We didn't get water from the city of Flint. And so while I wasn't personally involved directly, give people some ideas about what happened here, and talk through about how really this Flint water crisis wasn't a chemistry problem. We've known about how to do water chemistry for 140 years. And so this really is about a policy problem. It's about a social and environmental justice problem in relation to that. And so I'm going to give the talk, and then I welcome any and all questions people have about this. If there's one thing people who know me know, I'm an open book, and I'll give you an honest answer. And if I don't know, and you're still interested, I can certainly get back with you on that. Where I want to start is a slide that usually we show at a professional talk, but I think also it's important for students to understand what is U of M Flint? Where are you at? So we are regional comprehensive, centered in the downtown area of Flint, Michigan. The main corner of our campus sits at the main four corners of downtown. We were originally designed as Flint College, a liberal arts college. We are shifting more towards being a technological institute. So our main focus now is innovation and technology programs, science programs, healthcare, health science portions. And then the liberal arts is kind of here to support us. And so we have around 6,000 total students, graduates, and undergraduates. In our green chemistry and biochemistry department, we have 8 tenure track faculty, and we have around 60 majors. But really that number is about 45 or 50 majors and 10 to 20 majors who are constantly swapping back and forth between biochemistry, molecular biology, human biology, as they decide their best pathway to be pre-professional. So we have a lot of our majors that end up being pre-professional: dental, pre-pharm, pre-med, pre-PA, pre-PT, pre-OT. And so that's just kind of like a lay of the land. And then that star right here kind of gives you an idea geographically of where we are at in Michigan. I know everybody in Michigan always holds up their hand to show where we're at, but that kind of gives you an idea. So Flint's about an hour from just about everywhere in Michigan. We're about an hour and a half to Grand Rapids, an hour to Lansing, an hour to Detroit, hour and a half to the Ohio border. So one, I want to, before we talk about the water crisis, talk about, for those who may not know, how do we treat water and what does water treatment look like? So typically, you have a water source, you're going to have coagulant chemicals that you add, and those, whoa, don't go forward. Those coagulant chemicals are going to be added. You get coagulation of particulates in there. You get flocculation, which is really getting all of these tiny little particles in there to aggregate together. You get large clusters of things. You get sedimentation, so these things will settle out of solution, and then you filter those things off. Help get rid of, if you think about, you can go look at a river flowing down and all of the sediment and everything that's in there. How do we remove that? Well, some of it is the things that are solid, you just filter. But also you can add chemicals in the process to help get rid of other things that are smaller that may not work through filtration to aggregate, coagulate, you flocculate them, and then you precipitate them out. And here there's this thing called disinfection. And that is a loaded word. It is not just disinfectant for bacteria. So typically at some point between when the coagulant chemicals get added and this disinfection process, there are three main things that happen that are all at the center of what happened here in Flint. One, water is likely going to have organic molecules in it, a variety of organic molecules that are going to be in the water stream. And typically what you do is you use what's called an advanced oxidation process. You oxidize the organic chemicals so that you can remove them from the water stream, or in some cases, the oxidized version of the organic is considered to not be harmful, and it's okay in some levels to be there. When you get to the disinfectant stage, most water treatment facilities use chlorine. And so you add chlorine, and the chlorine will remove all the fungi and bacteria that might be in your water, so that when you drink the water, you don't end up getting sick. And the third piece is, and this is after disinfection, before you hand this out to the community, is it's very important that you add some sort of corrosion control. You add something to the water to help make sure that this water isn't going to corrode your pipes. And in most municipalities, it is some mixture of carbonate or phosphate, depending on what kind of metals you would expect to be inside of your water. And so those are the three key pieces to that. And so here in Flint, the problem initially is this. Before we get there, I need to specify why that corrosion control is so important. So you have pipes here, and can you see the mouse when I move it or no? Okay, so without any phosphate, you can get corrosion of your lead pipes. And so you have oxygen, lead 2+, chlorides, and things like that floating around. Depending on the pipe, if it's iron, you can get iron particulates floating around, and you can end up in a scenario you have high lead concentrations or high iron concentrations. And in scenarios we have high iron concentration, that's also a scenario that can promote the growth of Legionella pneumophila, which is the bacterial growth that creates Legionnaire's disease. If you have corrosion control, adding in your phosphate, you build this really nice passivation layer that protects all the lead from all the other corrosive things coming through there. And if you had general chemistry, a value that we use to talk about this is something we call KSP. And so if you have phosphate floating around inside of your pipe, in this case, particularly as it relates to lead, it has a KSP of about 3.0 times 10 to the minus 44th. What essentially that means is if you have any lead ions in water and you have phosphate present, that lead phosphate is going to form an ionic salt, and it's going to precipitate out a solution, and it's going to build a layer right on the surface of this pipe that protects it from having access to the real raw lead metal that is associated with the pipe. The issue is when you start having things like chlorine and oxide and other things there, you can start to leach away at that layer. And especially when you have high presentation of chloride or chloride ions, you can start to form lead 2 chloride. And even if you don't know anything about solubility, what you can tell is that lead 2 chloride has a KSP value here of 1.6 times 10 to the minus 5th. That value is substantially higher than what it is for lead phosphate. And what that means is you start to solubilize lead. And as you start to solubilize lead, that phosphate layer gets more and more eroded. And now those chlorides don't have access to a lead phosphate layer to dissolve lead. They have access to actual lead on the piping itself. All right. And so it's very important that corrosion control exists. What happened in Flint is Flint never treated water here. For decades, the water treatment facility in Flint was not a water treatment facility. Our water came from the city of Detroit, which has arguably the best water in the country. And the water was piped up to Flint, Michigan, and along the pipeline, all the cities that are connected to Detroit water didn't do water treatment. They were what we call a water supply distribution system. So this water from Detroit, already treated, came into the city of Flint, and the wastewater treatment facility just redistributed that water out to the city of Flint and the surrounding areas that were connected to it. So the Flint city did not do any water quality treatment. They were just redistribution. And so what happened chemically, before we get into what happened logistically, is this. When the city of Flint started to treat its own water, the organic materials in the water were not oxidized out. That advanced oxidation process wasn't done. Why wasn't it done? Even though it is a state mandate that happens, nobody in the state was checking with the water treatment facility on how they were going about treating their water. So organic materials were not oxidized out. Well, what was that next step we talked about? Getting rid of the bacteria in the disinfectant phase. So you start chucking in a bunch of chlorine disinfectant into a solution now that is filled with organic molecules, and chlorine started to react with the organic molecules. it started making something called trihalomethanes. In the process of making trihalomethanes, the other side of that is you end up with chloride ions that are in solution, and these trihalomethanes are corrosive. They start leaching at that passive layer that we have inside of our piping. So we have this passivation layer where we're going to have lead phosphate, which maybe would have been okay. But the third thing was they didn't do phosphate corrosion control. The state did not mandate, the EPA or the Environmental Protection Agency in Michigan did not mandate that the city of Flint add phosphate corrosion control. So 3 of the key components to treating water just were not done by the city in the process of doing this. And so without corrosion control and without oxidizing the organics, you make trihalomethanes, and those trihalomethanes erode the phosphate layer, and you end up with solubilized lead inside of the water. So that is the chemistry piece of how we ended up with lead in our water here in Flint. And that is something that we cover in general chemistry here on our campus. These slides are from my general chemistry class. We talk about solubility product. But the chemistry wasn't the problem. The chemistry was the problem because we didn't do what we were supposed to be doing. So because we didn't do what we were supposed to be doing, a lot of things ended up happening down the line. So what really happened here is Flint got its water from Detroit, and we had these really beautiful lead pipes all throughout the city that had this really great white corrosion control on there. City of Flint has no money, was on the verge of bankruptcy. City of Detroit charges what they say is an outrageous amount of money for water. The city, in the county we live in, they were building their own pipeline. They were in the process of building their own water treatment facility and building a pipeline directly to Lake Huron. And that Lake Huron pipeline was going to bring water straight from Lake Huron into Genesee County. They were going to do water treatment in Genesee County and distribute it to the Saginaw watershed area. So where I live in Grand Blanc would have gotten access to this water so that we could all remove ourselves from the Detroit water system because of the cost. The city decided we're not going to renew our contract with the city of Detroit, but the pipeline's not built yet. And the city decided, who was under emergency management from the state, the state was now controlling the city because they were in charge, said, we're going to treat the water ourselves and we're going to do it from the Flint River. So they took the Flint River water to a place that for 30 years had only been a redistribution of water, not a treatment center, and started treating it. So on April 24th, a worker named Mike Glasgow, he was a supervisor at the water treatment plant, said he did not think it was a good idea to switch. He said, I don't think we have the capability to do the switch on this water treatment. We just don't have the ability to do it. And on April 25th, they flipped the switch. And on that day, April 25th, water was no longer flowing from Detroit into the treatment facility. It was flowing from the Flint River. So April 25th, 2014 is technically the day that the Flint water crisis started, because that switch caused a lot of things. I do want to point out up here, this picture up here in the upper right-hand corner is the Hamilton Dam, and we'll come back and talk about that in a second. This Hamilton Dam crosses the 2 parts of our campus, so we'll show a picture later that shows it. It was the dam at the center of our campus, and so that just is a good picture from campus showing the Flint River. And we started to do treatment. In June, although it wasn't announced until much later, we started seeing Legionella disease break out in the city, at certain parts of the city. And so over the summer, we had boil water advisory effects in place. And you can start to see the water here coming out of the treatment facility, whether it's coming from the river or coming from Detroit, and how they were handling it. In August of 2014, the city announced the boil water advisory part for this part of the city. August 20th, they issued another warning that carried into September. And here's the interesting thing. In September or October of 2014, we have Flint Truck and Bus, which is the largest GM factory in the world, in our city. They discontinued using Flint tap water in their production facility because it was corroding the engines they were trying to build. Why was it corroding the engines they were trying to build? Because as a part of this issue, when we started getting bacterial growth and we realized, hey, what's going on? We said we need more chlorination. And so they started chucking in more iron chloride as a way to help treat some of the stuff that was causing Legionnaire's disease. And yet they still were not adding more phosphates. So instead of trying to create a bacterial solution, they were actually exasperating all the other problems that really were kind of hidden. And so all of these chloride salts are floating through this water, and the General Motors decides we're not going to use it. So this picture here is from January of 2015. This is residual parts of our wash basins in our labs on our campus from the water. And the next picture is my favorite picture maybe that I have. It's depressing, but it's so in early 2015. Now this is again before anybody's recognized there's an actual problem with what's going on. That picture is the water that was coming out of the faucet in my research lab. So that is a lot of iron and other things. Technically speaking, by turning on the faucets in our lab, if we weren't collecting the water, we were in violation of OSHA standards because the water we were pouring out of our taps was considered hazardous waste. So did that not? Oh, there we go. So in February, we started detecting lead inside of homes. And so you can see here a pipe. This is a pipe after the fact from other people's houses where lead is formulating inside of the pipes. That summer, the state government told them the water was safe. So in the summer, the governor and the state is telling people in the city of Flint, your water is safe to drink. The reason I want to point out this picture is this upset girl here with the headband on and the turquoise shirt's my daughter. And she was going to the development center on our campus who was getting food produced from local places in the community who are using Flint water to produce it. Again, everybody's saying nothing's wrong, even though from 2014 till this time, 87 cases of Legionnaires have been developed inside the city of Flint. And then there have been 20 deaths in relation to that. The federal action level for lead in water is 10 parts per billion. The largest number that was recorded during the height of the water crisis was just under 20,000 parts per billion in somebody's home. So it wasn't until September that anything happened. So all of this is going on. GM's not allowing us to use the water. The city's telling us the water is safe to drink. And it wasn't until October that there was a pediatrician in the city, Dr. Mona, who had a facility right next to our campus, who actually didn't talk about the water having lead in it. She was detecting it in children's blood. So there was an uptick in lead in the children in the city of Flint who were drinking water that the government was telling them is safe to drink. And so in October, the county issued an immediate no drink warning, still not coming from the state. And so there's a map, and I gave this link that you probably got shared out at some point that is an interactive map that kind of shows you from October of 15 to February of 16, the different levels of lead that were kind of populating throughout the area. And in October of 6/15, we switched back to Detroit water. So we only used the city water for about a year and a half. But the issue is the corrosion was so out of control that you have to have a phosphate layer. So even though we switched back, it's not an immediate solution. All that corrosion layer has to be rebuilt back up with a passivation layer. And so people were really struggling with water even after we made the switch. And just to give you an idea, one of the people around here who was given a lot of praise during this time was the rapper Eminem, because he was continuously donating water to the city of Flint. And so you'd see in the news him at the local church with 100,000 bottles of water for the city. But when you really break it down, that's enough for everybody in the city to have 1 bottle of water a day for one day. And if you look at that picture of the water I showed you, I mean, most of you in your homes, if you had the water that was in that beaker coming out of your tap, whether or not you chose to drink, it's one thing. You probably weren't even going to shower or bathe with it. And so it was a lot of things that were going on there. Now, what I want to point out here is July of 2015, state government tells them the water was safe to drink. This is a map of our campus. And so right there's my office. I am right in this window right here, right now. And this is our science building. This is our new science expansion. Here's the remnants of the dam that we showed you. And we have campus over here. Right here, this building right here sits at the center of our campus, and it's a state of Michigan building. So there's a lot of social services for the city of Flint that are run by the state or downtown. And in July of 2015, while they're telling all the residents of our city that the water is safe to drink, there is daily shipments of bottled water coming to that state building so their employees don't have to drink the water inside of the building. And so it's just a real issue in all of this and how things were disseminated, how things were controlled. So we said on the last slide that we shifted back in October 15. In 2016, our brand new building, Murchie Science building that I'm in, had been renovated. All of our fume hoods, I don't know if any of these students have ever seen a fume hood, but we have backflow valves up the top of them. Those black backflow valves had leaks in them perpetually. We have cups hanging from them now because they were ruined the day we opened them in 2016, a year after we had switched back. So there's been a lot of updates over the years. First responses were to give out filters and flush systems and directions to people. But All of those directions were sent out in English. About 15% of the city of Flint are non-native English speakers. And so not only that, the really bad thing that happened here was somebody called Pure about the filters they were being given for their houses. And Pure was given the wrong part number and told the citizens, yeah, those filters aren't going to work for filtering out lead. It was a mistake, but you can imagine how the people in the city felt. The city's giving us filters to filter our poison water, and it's not really poisonless. Phase 2, we started replacing lead service lines, massive amounts of infrastructure upgrades and everything, and all of that is going on exterior to houses. There was money available to do it inside of houses, but people were afraid to let the city in to order to replace those service lines. Updated data from 22 is we're now at a point in the city where there are 0 known lead service lines still in the city. They had replaced all of the known ones. There are still about 16% of service lines that we're not sure about, where either the people won't let them detect, they won't let them know. So we have done a really good job in Flint. What I want to point out to you is, if you look down at Jackson, Michigan, which is down here about an hour and a half from us, 94% of the service lines in that city are still lead to this day. As long as you treat your water okay, everything's going to be okay. But if you mishandle that, you can imagine that 94% of the population is going to immediately have issues in the drinking water that they had. And so there's a map here, and I can send this. I think I sent this to Dr. Prescott. If not, I'll send it again. There's a place in the city where you can come in and you can put in your address, and it'll tell you whether or not they believe you have likely lead service line in your house, and you can then get it replaced. This house here, I drive by every day on my way to campus. It was the last house for 3 years that refused to have their lead service line replaced. So we were sitting at like 99.999% completion rate. And as of a month ago, whoever bought the house had the service line replaced. The lead values have dropped. So early on in January of 16, because they don't have great data during the height of the crisis, they didn't admit there was a problem. It was well over 20 parts. Ever since we've switched back, notice it took a little bit for that to drop off as that corrosion control layer got rebuilt. And then it stayed below the federal limit for the most part ever since then. The last piece I want to mention is that longitudinally, what are we going to do? My daughter may or may not have been exposed to lead. We're not sure. So there are symptoms that you can detect. But the issue is that when you do blood testing, so they take your blood and they check for lead, it only presents in recent exposure within the last 60 to 90 days. So if somebody was exposed to lead during the water crisis, it's not still in their bloodstream. So what they're doing now is they're actually doing tests in the city, and there is a big conglomerate of people associated through the Flint Registry, Michigan State University, Hurley Children's Hospital, doing this thing called the Flint Tooth Fairy, where they're asking children in the city and adults as they lose their baby teeth to donate them to the study. Because what happens is inside of your teeth, you start collecting layers in your teeth the way that a tree would. So that even when you're in utero, you start to develop your teeth and you get these rings in them over time, just the way a tree does as it grows by season. And your teeth have these same layers in them. And so what you can do is you can actually detect if somebody has been exposed to lead in their baby teeth, if they were exposed even when they were in utero being developed. And so they're using this now to help track some of these children to say, when were you exposed to lead? And the only reason they're using baby teeth is they fall out naturally. So they're asking people, as you lose your tooth, let's collect it. They don't want to go in and start extracting teeth from people. And so we're in a long-term scenario here. The money that the state of Michigan was required to give out still hasn't been given out. $340 million to the residents of the city of Flint who were affected still has not been paid out to this day. It is still hung up in courts fighting over it. But the city, it's just an interesting dynamic. So here's that dam that I talked about. This photo is from like 1910. That dam was in our city for a long, long time, and it was directly downstream from all the auto manufacturing. The campus where our university sits was a coal gasification plant, so our soil has a lot of antimony, lead, arsenic, and other things there. It was considered the biggest ecological disaster in the state because of what would happen if that dam had broken. Directly down from that, we have Chevy in the Hole, which was the main site for the original Chevy plant. That place right there in the city of Flint, about half mile from our campus, is where the Chevy Corvette was first built, tested, and modeled. And then because of the water crisis, the state finally took the river serious, which the river wasn't the issue, but they started a restoration project in 2018, dredging the river to remove all that soil, to eventually remove the dam. So you can see a picture of an excavator pulling out the soil. The downside is they dried it in a vacant lot about 200 yards from our building. So for that summer, you can imagine if somebody was drying out raw sewage next to your house, what our campus must have smelled like from May till about mid-October. Basically, dredged it, let it air dry, and then they hauled it off site to go take care of it. And the reason they did all this was to help restore part of downtown. So that dam that I showed you in that earlier photo now looks like this through the center of our campus. That was phase one. That was phase one. They're going to have another phase two. That Chevy in the Hole is now called Chevy Commons. Genesee County was the only county in the state of Michigan without a state park. They're now commissioning it as a state park. And this river is going to connect all the way out to the Saginaw Bay. So we'll actually be able to do like native sturgeon fishing and stuff in the Flint River eventually as the populations come through. And so this building here is part of campus. So this runs right through the center of campus now. And when they start doing phase two, they're actually going to be putting in kayaking drop-in and offs right next to our campus. So by the end of 2026, probably in the spring of 27, it's likely I'll own a kayak because I'll be able to walk out from my office and go down to the river about maybe 100 yards from here and drop in if I wanted to, and then kayak the Flint River. It's a very beautiful part of the city. And so the moral of all of this is that the water chemistry is there. We know it. It's a societal issue. I saw a talk from a gentleman from Kettering who's a social scientist. And really, when you want to talk about when did the Flint water crisis start, the official is April 25th, 2014. People in the city will say it was when they started to oppress certain populations of the city and controlling where they could get loans to buy houses and all of the oppression that was going on in the city for decades. Some of it, there's a lot of different pieces there. And I will say that it's a long time that it's going to take to help rebuild the trust with what happened in the city. And you might say, well, how does this tie into green chemistry and why are we so passionate about it as green chemists? Well, if you look at what happened in the Flint water crisis, it affected people. It certainly had an impact on the society, right? What happened was certainly a policy problem. Chemistry was part of the problem, the fact that we weren't doing it appropriately, and also then part of the solution and how we addressed it. And ultimately, what kind of resources were we providing, did we have for people to help alleviate what was going on during that water crisis? And from our perspective here, those four things really all sit at the center of what green chemistry is about. It is about doing chemistry the right way with safer alternatives and resources, lower energy resources for a better society, and helping educate people to develop better policy when we have these things occurring so that it doesn't happen in the future, and that we have a path forward for that. And so that is really what spawned us creating this program here, centered on everything we went through within that Flint water crisis. So with that, I do want to thank Dr. Jessica Tischler. Some of the slides there are stuff that she has presented on in the past. The faculty in the Green Chemistry Biochemistry Department, because they're supportive of all the stuff that we want to do. The College of Innovation Technology that I'm in, who really helps foster, along with Beyond Benign and the ACS GCI, who support what we do, and Dr. Prescott for inviting me to give a talk. And with that, I will answer any questions anybody has or any commentary, and I'll leave the slides up in case somebody wants me to go back and say something.
Awesome. Thank you, Dr. Kingsley. That was an amazing tour through that entire story, and I really appreciate the passion that you have for sharing exactly how this all came about and kind of how things happened and weaving into the chemistry into the story too. Just a fantastic presentation. So we do leave it open now for questions from students. So you can feel free to put those in the chat for Dr. Kingsley, or you can just unmute and say them if you'd like to. So I will kind of shift over to that. I think you have access to that too, but I'll just read the first one out. So thanks. Cynthia's asking, heard rumors that acrylic paint doesn't get filtered out during the process of filtering water, particularly that it doesn't get coagulated with the rest of the potential contaminants. Is this true?
It is certainly true, depending on the size of the acrylic paint particulates. I don't know. I don't know the cutoffs for those. I don't know what the sizes are, but that is certainly an issue in water quality, in water treatment. That is certainly an issue. And I don't know the precipitation. Yeah, acrylic paints do not coagulate very easily. And I don't know where the problem exists most likely, but I do know that that is an issue. That is definitely an issue. But I don't think it's prevalent everywhere. I think it depends on the industry you have around them. So like wherever there's like paint manufacturing and things like that, I think it's a bigger concern, or how they're doing waste streams for like landfills and things like that, right?
And what advice do you have for chemistry students who want to apply green chemistry principles to real world problems like Flint?
There is a lot of ways that you can do this. One, educate yourself. Two, share the narrative with other people. Two things I think that are important is you're never going to change somebody's narrative by educating them, because you're not going to be able to, you're not going to say, oh, you just aren't knowledgeable on this, so let me educate you on what the problem is, and therefore you're going to see my side. That's not going to happen. The best you can do is be an advocate for it. I think that being involved at the local level in what you're doing can be a great resource. Dr. Lloyd Baston at Widener University does a project with his students where they go to their state capital every year. They pick a bill that's coming up, and the students do a green chemistry sustainability analysis of something within that bill. And they go and meet with their state legislatures and talk to them about the bill that's there to help make them knowledgeable about what's going on and help them become aware in things. I think that's a way to do it. And then see what kind of opportunities. So for example, we had a student in my class who took green chemistry with me, who was going to be a physician's assistant. Their entire path was dedicated to that. Took my green chemistry class, and now they work for the Army Corps of Engineers doing water quality remediation in the St. Clair Lake and Detroit River, because that's their way. They want to be passionate about helping people. So it's getting involved and trying to make yourself educated on what's going on to make a difference.